Assalamu alaikum. Hello, hi to everyone. You're listening and watching to my channel Learn All here. Today we will discuss important topic, important gate of logic designs, important logic gate which is known as the Nand Gate. First of all, before discussing the Nand Gate, we must know what is AND Gate. Before discussing the AND Gate, we will find out what does the AND operation means. For example, if you have a condition, if a number, suppose a variable a is greater than 5 and a is also divisible by 2. This statement says that if both the conditions are fulfilled, then result will be obtained. Which means, for example, if you have a number 10, we will check both the conditions, whether 10 is greater than a and 10 is divisible by 2. 10 is greater than 5. First condition is fulfilled. Now we will check, is 10 divisible by 2? Yes, it is divisible by 2. The answer is 5. It means that both the conditions are fulfilled. Therefore, we will obtain a result as true. AND operation means that if both the conditions are true, then a high output or one output or a true output will be obtained. If any of the condition is false, then no output will be obtained. For example, if we have a number 9, we will check both the conditions. 9 is greater than 5. Okay, first condition is true. Now we will check the second condition. Is 9 divisible by 2? No, 9 is not completely divisible by 2. Therefore, one of the condition is false. It means we will not obtain true or high result. AND gate means we are using the multiplicative property, which means if you have both high results, your output will be high. If you have one true result, if you have one true input but other condition is false, then output will be false. Similarly, if the first condition is false and the second condition is true, output will again be false. And if both the conditions are false, the output will be false. This is somehow a truth table of AND gate. And now if we take it in terms of zeros and 1, we can write 0 0 1 1 0 1 0 1. These are the inputs. We will take their output, that is, if both the conditions are false, the answer is false or low. If any one of the condition is false, answer is again false or low. Similarly in this case, now if both the conditions are 1, then the answer will be 1. So this is AND gate, which holds the multiplicative property that if both the conditions are true, our result will be true. Now we shall look at the NAND gate. NAND means not plus AND. It is simply inversion of AND gate. It means that whatever is the output of the AND gate, it will be inverted and the inverted output will be of the NAND gate. NOT operation means inversion. That is, if any input is true, its output will be false. If any input is false, its output will be true. We will revise the truth table of AND gate. The truth table of AND gate is as follows: 0 0 0 1 1 0 1 1. We will take the output 0 0 0 1, and after inversion says that high will be transferred into low and low will be transferred into high. So 0 becomes 1 1 1 and this one becomes 0. This is simply NAND gate output. NAND gate is a universal gate. Universal gate means such a gate from which all the other logic operations can be obtained. We can use NAND gate to make AND gate, OR gate, NOT gate, XOR gate, and as well as XNOR gate. The IC number of a NAND gate is 7400, and we know that an IC 7400 has 14 pins, 7 pins at the beneath, 1, 2, 3, 4, 5, 6 and 7, and 7 pins at the top, 1, 2, 3, 4, 5, 6, 7. We will number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. This is IC of the NAND gate, and we should know the configuration too. Which pins will be of input and which pins will be of output. The 1 and 2 pins are of input, whereas the third pin is of output. And these 3 pins constitute one NAND gate. Similarly, the 4th and 5th pins are input, the 6th pin is output. This means these 3 pins, 4, 5, 6 pins constitute the second NAND gate. The 7th will be grounded, and now the 14th will be supplied VCC, that is our input voltage, which is required in the operation of any device. Here the 9th and 10th pins are inputs and the 8th pin is again of output. It means 8, 9 and 10 pins constitute the third NAND gate. Similarly, the pins 12 and 13 are for input and the 11th pin is for output. It means 11, 12, 13 pins constitute the 4 NAND gates. It means a single IC 740 contains 4 NAND gates. You can use these NAND gates to build up any other logical gates. Now we shall study NAND gate as a universal gate. As we have discussed earlier, that what is a universal gate? A gate is known as a universal gate if it can be used to build all the other logical gates. NAND gate is a universal gate as well as NOR gate. That is the inversion of OR gate is also a universal gate. Using NOR gate as a universal gate will be discussed in the next tutorials. Now we are discussing that how we can use NAND gate as a universal gate. First of all, the question arises in our mind that why should we use NAND gate to build other gates? The answer is that sometimes we do not have all the right apparatus for our circuit. For example, if you want AND operation in your circuit, or if you want OR operation in your circuit, but you don't have the available gates or available ICs. So what can you do? You can combine the NAND gates to form the AND gate, which is the requirement of your circuit. Similarly, you can combine the NAND gates to form the OR gate. That may be the requirement of your circuit. So now we will discuss that with this only one IC 7400 with the 14 pins, how it can be used to form NOT gate, AND gate, OR gate, NOR gate and XOR gate, also known as XOR gate. First of all, we will theoretically form the NOT gate and then we will find out the pin configuration on the IC so that it becomes easy for you to perform the practical too. So first of all, we must discuss the NOT gate. For NOT gate, you just require a single NAND gate. For example, this is a NAND gate. What you have to do, just short their inputs. It means that whether you use X input or you use Y input, it will behave the same. X is equal to Y is equal to X. They will behave the same. And what will you get the output? Since it is only one input, now it will be considered one input. They won't be considered as two different inputs, as we have short them with a wire practically, and in this case we have short them, so it will act as a single input. So we consider that our input is just X. So what we will get the output? X bar, which means inversion of X. If you want to draw the truth table, you can say you have X and X bar. You have number of inputs just one. So the total number of combination would be 2 raised to power 1, which is equal to 2, 0 and 1. These are the two number of combinations we have got. So inversion of 0 is 1. Inversion of 1 is 0. See how easily you can form NOT gate from the NAND gate. Simply what you have to do is to just pick up one NAND gate. By using one NAND gate, you can form the NOT gate. And what would be your operation? You would just have to short the two inputs, which will act as just one input, and you can get the output. Now, this was something theoretically. If we want to see how can we perform it practically, then what you have to do, take IC. Remember the number IC 7400. Remember the pin configuration 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 provides VCC, your supply voltage, and 7th pin is for grounding. Remember, grounding is very important in any circuit, otherwise your circuit won't work. And one thing is important to remember, that only supply 5 volt VCC. On your logical trainers you have different supplies, plus 5 volt, 12 volt, minus 5 volt, but you have to supply the plus 5 volt, because otherwise your IC would not work properly, or it would burn out, or its operations will be not well performed. So apply its volt 5 volt. And now let us mark the pins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14th pin. According to the theory, we have seen that we need only one NAND gate. And how is the one NAND gate formed? It is formed from the first 3 pins, which means the first, second pin acting as input and the third pin acting as output. What you have to simply do, take a wire, a short wire, and short these 2 inputs. What will they act? They will act as a single input. What you have to do, whether take a wire here and connect it to any switch, say S1. You understanding this? Connect this to any switch S1. Similarly, if you don't want to do this, you can also take the wire and connect it to any switch 2. Just do one thing. Connect just a single wire to any of the switches, whether in pin 1 or with pin 2. It will act as a single input. And you know what is your output pin? That is the third pin. Connect the third pin to any of the LEDs, say L3. When you will supply the voltage, turn on your logical trainer, what will happen? It will, when you will turn the switch on, the LED won't glow. And when you will turn the switch off, the LED would glow. That is, we have obtained the inversion, the NOT gate, using the NAND gate. So this is very simple, using only one NAND gate. Now if it comes to AND gate, number second operation, AND gate. That is, how could you obtain the AND gate from NAND gate? We have earlier discussed that what is NAND? NAND is NOT plus AND. Now if you once again add NOT to this NAND, what will happen? This NOT and this NOT will cancel out and you will get the AND gate. Well, this was something really pseudocode type, and we will also prove it theoretically as well as practically. This was just to make you understand that when you take the two NAND gates, they cancel out their operation and form a single AND gate. For example, you have a condition or any variable A. You are inverting it, A bar. You are again inverting it, A double bar. It actually forms the simple A. For example, you have input 0. You are inverting it, it becomes 1. You are again inverting it, it becomes 0, which is the original one. So it means that to form the AND gate, you just need two NAND gates. How? Let us form them. First NAND gate, input X, input Y. This is NAND gate. Now what you have to do? First of all, write down what output will you get here. You will get X dot Y bar. Bar is due to the NAND gate. X dot Y is operation of and bar is due to the NAND gate. We have obtained the NAND operation. We want to convert it to the AND operation. Simply we will invert it. How we can invert it? Again using a NAND gate, but making it single input. Now this second NAND gate simply acts as a NOT gate or as an inverter. It means that first of all you have obtained the NAND operation, and then by simply applying an inverter you can again obtain the AND operation. Let us see how we can do this. This output becomes input for this NAND gate, and we can say X dot Y bar, and due to this NAND gate we will put 1 bar again. Bar cancel out each other. It becomes X dot Y, which is simple the AND gate. Let us also prove it by the truth table. We will take our inputs X, Y. First output X dot Y bar and the X dot Y double bar. Let us prove them. 0 0 0 1 1 0 1 1. What will NAND give us? NAND will give us 1 1 1 0. Again inverted. 0 0 0 1. Isn't it the truth table, the output of AND gate? How simply you can obtain AND gate by using NAND gate, by using just two NAND gates. Simply we have proved that when you use a NAND gate and then use a NOT operator with it, you can form the AND gate. And NOT operator you have to use in the form of NAND gate. You cannot use a NOT gate because we are totally using the NAND gates in this operation or in these study, because we want to use the NAND gates to make the other gates. And in the previous study we have find out that how we can make the NOT gate from NAND gate by just shorting the two inputs and considering them as a one input. The same thing we have done here. We have shorted the two inputs and make them as a single input for this second NAND gate. Now if you want to see the practical application or the practical use or how we can practically verify it, again simply take your IC 7400. Remember the number, pin number 1, pin number 2, 3, 4, 5, 6, 7. 7th pin always grounded. 8, 9, 10, 11, 12, 13, 14. 14th pin we supply VCC. Remember VCC always must be 5 volt. Just follow your circuit. What you have done, you have supplied two inputs. It means pin number 1, pin number 2. Give it to switch S1, give it to switch S2. Output will be obtained at pin number 3. Now you do not connect this output to some other LED, because if you would connect this output to the LED, it will give you the NAND gate. It will give you the output or verification of the NAND gate. but we want the verification or output as the AND gate. So what you have to do? Simply do one thing. Just take this output and make this input for these two. Short them. First of all, what you have to do, short the 4th and 5th pin. They will be considered as a single input. Now what you have to do, take the 3rd pin and short it with them. Following a circuit diagram, this output at pin number 3 becomes input for the one input which was actually the 2 input, but we have shorted them. This 3rd becomes input for the 4th and 5th pin to give output at the 6th pin. We will take the output at the 6th pin. Remember these, you cannot change the configuration, the pin configuration of the inputs and outputs. You will always have to take the inputs as pin 1, 2, 4, 5, 9, 10, 12 and 13. You can never take the inputs at any other the pins, and you will always have to take the output at pin number 3 in case of NAND gate. In case of NOR gate, it's a bit different, but now we are studying the NAND gate. So in case of NAND gate, remember you have to take the output at pin number 3, pin number 6, pin number 8, 9, 10 will be for inputs, pin number 11 will be for output, and 12, 13 will be for input. Remember, always remember 3, 6, 8, 11. These pins are for output in terms of a NAND gate when you are using IC 7400. So what have you done? You have supplied the switches S1, S2 separately at the pins 1 and 2, and you are taking output at pin number 3 for this first NAND gate. Now using the second NAND gate, what will you have to do? You have to just short the pin number 4 and 5 and the output at 3 will act as the input for these two pins, because we are not supplying any separate inputs for these two pins. We are not giving them any switching from any of the switches S1, S2, S3, S4 and so on. We are giving them input from the output of the first NAND gate. The input of the second NAND gate is actually supplied by the output of the first NAND gate. So you are shorting them and you will obtain the output at pin number 6. Connect pin number 6 to any of the LEDs, say L4. It will verify your AND gate. For example, when you will turn both the switches off, the output will be low because both the conditions are false. When you will turn S1 on and S2 off, the output will still be 0 because one condition is not fulfilled. And when you will turn S1 off and S2 on, output will still be low, 0, because one of the condition is not fulfilled. But when you will turn both the switches on, both the switches will be at high, the LED will glow. It means we have obtained our truth table 0001, which is of NAND gate. So it is very simple to form a NAND gate from it is very simple to form an AND gate from a NAND gate by just using two NAND gates and to correctly identify the pin configuration of your IC. Always remember the pin configuration of your IC, that is the pin number 3, 6, 8 and 11 are for outputs in term of NAND gate. So we have so far built two logic gates by using NAND gate. Now we will come to our third gate, which is OR gate. Let me make you revise what is an OR gate. For example, if you have a condition, if A is greater than 5, I'm writing the same condition but with a different operator. Or A is divisible by 2. Then your result will be high. For example, I take a number 7. I will check the first condition. Yes, the number is greater than 5. First condition is fulfilled, but the second is not fulfilled. So what? You have an operator OR. It means OR operator means that if any one of the condition is fulfilled, you will get the result high. But if both of the condition are false, the result will obviously be low. If you have a number 3, the 3 is neither greater than 5 nor it is divisible by 2. So your output will be definitely false or low. So let us formulate its truth table. When both the inputs are low, false, answer is low. When one is low but other is high or true, the output is 1. When one is high, other is low, again 1. And when both are true, well and good, output will be 1. So this is the revision of OR gate. What does an OR operator means? It is also known as the addition property in terms of Boolean algebra. In terms of the Boolean algebra. Now we will have to form the OR gate by using Nand gates. I will give you a rough sketch that you will have to use the 3 Nand gates to make up an OR gate. Theoretically, let us see how we can perform it on our paper, and then we will look it as practically. First of all, what you should do, take 2 Nand gates. Do one thing, short their inputs. Now what will happen? This will act as just X, this will act as just Y. Now their outputs will act as inputs for the third Nand gate. Write down the operation here. What you get here? X bar, because it is converted into a NOT gate. What you get here? Y bar. And what you get here? X bar dot Y bar whole bar due to Nand gate. So let us formulate its truth table. What we have? X, Y, X bar, Y bar, X bar dot Y bar, and then X bar dot Y bar whole bar. Writing it down, 0 0 0 1 1 0 1 1. Invert 0 1 1 0 0 1 0 1 0. Now take the end of these two. 1 1 answer gives 1, 1 0 answer gives 0, 0 1 0 0 0. And now invert them. What you will get? 0 1 1 1. Oh look, it's matched with the truth table of OR gate. It means that you have formed the OR gate using the Nand gates. And what we have, you can also prove it theoretically by De Morgan's theorem. Let me make you revise what are the De Morgan's theorem. For example, you had the output X bar dot Y bar whole bar. Okay. Now applying the De Morgan's theorem, what will happen? Just write these two same. Whatever you have literals, whatever you have variables, just write them as it is the way are. Now the upper bar, the bar which is the main bar, it will divide on them too. It will come on to this, it will also come on to this. And what will happen? Bar is always something like inversion, something like complement. So the dot operator will be converted into the plus operator. Simple. And I have already told that if a variable has double bar, it simply means it will originally give you that variable. So X plus Y is simply the OR gate. It simply adds up, which holds the additive property. So it is a way to theoretically perform or to theoretically prove that how can you make the OR gate from Nand gate. Now we will perform it practically, which is very important. Again, remember what you will have to take. You will have to take your IC 7400 with pin configuration. Pin number 7 will be grounded, pin number 14 VCC, pin number 1 2 3 4 5 6 7 8 9 10 11 12 13 14. 8 9 10 11 12 13 and 14. Okay, now simply follow. You have shorted the first two, short them and connect them to any one switch. Short the 4 5, connect them to any one switch. I said that if you follow this circuit diagram, the output of these two NAND gate will act as input for the third NAND gate, and our third NAND gate constitutes of the pin 8, 9, 10. That is, you will connect the third pin to the 9th pin and the 6th pin to the 10th pin. Then you can take the output at the 8th pin to any of the LED, say L3. This is the way to practically perform or practically prove OR gate from the NAND gate. Now this is something very interesting, that how can you build NOR gate from NAND gate? There are two universal gates, NAND gate and NOR gate. So it is very interesting to build one universal gate from another universal gate. Now let's see how can we do it. In the previous page or in the previous few minutes, we have made the OR gate from the NAND gate. You all know what is NOR gate. NOR simply means NOT plus OR. It means inversion of OR. So what you have to do, you have to just invert the output of the OR gate. In simple words, whatever, let us now draw the circuit that we have used to make OR gate from the NAND gate. This was the circuit, first NAND gate, second NAND gate, third NAND gate. Now what you have to do, take this input and short it with the two, take this output and short it with the two inputs of the fourth NAND gates. This one is simply a NOT gate, an inversion. Up till here you have obtained the output of OR gate, and after inverting you will get the output of NOR gate. There is nothing, no logic or no rocket science in this case. What you have to do is you had taken the output at pin number 8. Just pick it up, short the 9th and 10th and connect it to them. 9, 10 and 11 form the fourth NAND gate. So what you have to do, just short them, and this output at 8th gate will act as input for these pins, and take the output as the 11th pin to any of the LEDs, say L4. So as we are advancing, the number of NAND gates are increasing. When we used NOT gate, the number of NAND gates, when we wanted to build the NOT gate, the number of NAND gates was just 1. In AND gate it was 2, and in OR gate they were 3, and in NOR gate they are 4. It depends upon the operation on what we are applying, which type of operator we want to get from our universal gate, that is NAND gate. I hope this tutorial will help you to find out how can you use the NAND gate as a universal gate in building of the basic logic gates. If you understood something from my video, like, comment and share, and do not forget to subscribe to our channel. Learn all here. Thank you all.